Assalamu alaikum friends. Friends, hope so you all will be fine. Friends, in this video, I'm going to discuss about one of the most important short note and long answer question, and that is pyruvate dehydrogenase complex. Students, we will cover these topics under the heading of steps, regulation, and importance. Okay, before going into a discussion, let me discuss about little bit introduction of pyruvate dehydrogenase complex. Students, this enzyme, pyruvate dehydrogenase enzyme, it converts pyruvate into acetyl CoA. Pyruvate is a 3 carbon atom containing compound, and acetyl CoA, it is a 2 carbon atom containing compound, and this conversion takes place with the help of pyruvate dehydrogenase enzyme, and there is a removal of carbon dioxide and incorporation of coenzyme A sulfahydryl group. Students, this is the simplest reaction. It is an irreversible step, and it is also a committed step. This pyruvate dehydrogenase complex, it consists of 3 enzymes and 5 coenzymes. Okay, 3 enzymes. The first enzyme is pyruvate dehydrogenase. The second enzyme is dihydrolipoyl transacetylase. And the third enzyme is dihydrolipoyl dehydrogenase. Students, these are the 3 enzymes: pyruvate dehydrogenase, dihydrolipoyl transacetylase, and dihydrolipoyl dehydrogenase. Okay. Now 5 coenzyme. The first one is thymine pyrophosphate, which is derived from vitamin B1, and its name is thymine. And second coenzyme is lipoic acid. The third coenzyme is nicotinamide adenine dinucleotide, which is derived from niacin vitamin. The fourth one is FAD, flavin adenine dinucleotide, which is derived from vitamin B12, that is riboflavin. Okay, and the last one is coenzyme A, and it is derived from pantothenic acid. Pantothenic acid. So students, this pyruvate dehydrogenase complex, it consists of three enzymes and five coenzymes. The first enzyme is pyruvate dehydrogenase, second enzyme is dihydrolipoyl transacetylase, and third enzyme is dihydrolipoyl dehydrogenase. The first coenzyme is thymine pyrophosphate, which is derived from vitamin B1, that is thymine. The second one is lipoic acid. The third one is nicotinamide adenine dinucleotide, which is derived from vitamin niacin. And fourth one is FAD, flavin adenine dinucleotide, which is derived from vitamin B12, that is riboflavin. And the last one is coenzyme A, which is derived from pantothenic acid. These all complex responsible for transport of three carbon atom containing compound, that is pyruvate, to the acetyl CoA, which is a two carbon atom compound. These all complex are responsible for conversion of pyruvate to acetyl CoA. So how these complex, they are useful, they are used in conversion of pyruvate to acetyl CoA. So now let's see the steps of this complex. Now coming toward the steps. Now coming toward the steps of pyruvate dehydrogenase complex. Steps. Students, in first reaction, there is a removal of carbon dioxide from this pyruvate. Removal of carbon dioxide from this pyruvate and acceptance of hydroxyethyl group from pyruvate to thymine pyrophosphate. Let's see. Thymine pyrophosphate. Okay. Is thymine pyrophosphate, and it converts into hydroxyethyl thymine pyrophosphate. And this reaction, it is catalyzed by pyruvate dehydrogenase enzyme. There is a removal of carbon dioxide from pyruvate and acceptance of hydroxyethyl group from pyruvate to thymine pyrophosphate, which is converted into the hydroxyethyl thymine pyrophosphate. Now, next one, there is a use of dihydrolipoyl transacetylase enzyme, and this enzyme, it is responsible for the catalyzing two reaction. This enzyme catalyzes two reaction. So let's see. Now in next reaction, there is a transfer of hydroxyl group from this hydroxyethyl thymine pyrophosphate to lipoic acid. Okay. And this lipoic acid, it converts into it converts into acetyl lipoamide. Okay. This is the first reaction which is catalyzed by dihydrolipoyl transacetylase. There is a transfer of hydroxyl group from hydroxyethyl thymine pyrophosphate to lipoic acid, which is that converts into acetyl lipoamide. Now second reaction, there is a transfer of acetyl group from acetyl lipoamide toward the coenzyme A sulfhydryl group, and there is a formation of acetyl CoA, and there is also formation of dihydrolipoic acid. Okay, students, these two reactions they are catalyzed by dihydrolipoyl transacetylase. Okay, there is transfer of hydroxyl group from hydroxyethyl thymine pyrophosphate to lipoic acid, which leads to the formation of acetyl lipoamide. And in next reaction, there is a transfer of acetyl group from acetyl lipoamide to cu acid, and there is a formation of acetyl CoA and dihydrolipoic acid formation. It is a reduced form of lipoic acid. In next reaction, the third enzyme is used, that is dihydrolipoic dehydrogenase. And this enzyme, there is a regeneration of this lipoic acid, which is the oxidized form, which is in the oxidized form, and FAD, flavin adenine dinucleotide, gets regenerated by nicotinamide adenine dinucleotide. Okay, here this FAD plus converts into FADH2, which gets regenerated with the help of NAD plus, which converts into NADH and H plus, and in electron transport chain it gives 5 ATP. Okay, so this is the third step, which is last step, which is catalyzed by dihydrolipoyl dehydrogenase. Dihydrolipoyl dehydrogenase enzyme. Okay, students, these all are the steps of pyruvate dehydrogenase complex. In first reaction, there is a removal of carbon dioxide with the help of this enzyme, and this transfer of hydroxyethyl group from pyruvate to the thymine pyrophosphate. There is formation of hydroxyethyl thymine pyrophosphate, and this enzyme catalyzes two reactions. In first reaction, there is a transfer of hydroxyl group from this hydroxyethyl thymine pyrophosphate to lipoic acid, and it converts into acetyl lipoamide. And there is a transfer of acetyl group from acetyl lipoamide to COSH, and there is a formation of acetyl CoA and dihydrolipoic acid. It is a reduced form of lipoic acid. In the last reaction, which is catalyzed by dihydrolipoyl dehydrogenase enzyme, and here there is a formation of lipoic acid and FAD plus. It gets regenerated with the help of NAD plus, and NADH and H plus in electron transport chain gives 5 ATP. Okay, so these all are the steps of pyruvate dehydrogenase complex. Now coming toward the regulation. Regulation. There are two ways through which this pyruvate dehydrogenase complex gets regulated. The first one is allosteric regulation by products. Allosteric regulation by products. Okay, allosteric regulation by products. Okay, students, and here products like acetyl CoA and NADH and H plus, they inhibit they inhibit pyruvate dehydrogenase complex. And the second one is through covalent modification. Through covalent modification. And here I am writing here covalent modification. Students, this pyruvate dehydrogenase enzyme, it activates only in dephosphorylated condition, and it is inhibited in phosphorylated condition. And calcium ion, magnesium ion, and adenosine monophosphate, they favor dephosphorylated condition. Calcium ion, magnesium ion, and adenosine monophosphate, they favor dephosphorylated condition, while ATP and pyruvate dehydrogenase kinase enzyme, they favor phosphorylated condition. And in this way, the regulation of pyruvate dehydrogenase complex takes place. Allosteric regulation by products acetyl CoA and NADH plus, they inhibit pyruvate dehydrogenase complex, and covalent modification through phosphorylation and dephosphorylation. This pyruvate dehydrogenase complex, it activated by, gets activates in dephosphorylated condition and gets inhibited in phosphorylated condition. Calcium ion, magnesium ion, and adenosine monophosphate, they favor this state, and ATP and pyruvate dehydrogenase kinase enzyme, they favor this state. And in this way, regulation of this complex takes place. Now coming toward the importance of pyruvate dehydrogenase complex. Importance. Now coming toward the importance. Importance. Students, first one is, it is a link reaction. It is a link reaction in between glycolysis and TCA cycle. Okay, this is the first importance. The second one is, due to irreversible phenomena as pyruvate converts into acetyl CoA, due to irreversible phenomena, not all fat converts to glucose. Due to this irreversible phenomenon, not all fat converts into glucose except glycerol and propionyl CoA, which is the even chain fatty acid. So that's why all chain fatty acid. That's why even chain fatty acids, they do not produce glucose. Students, I'm repeating again. Due to irreversible phenomena, not all fat converts into glucose except glycerol, which is the part of fat, and propionyl CoA, which is the odd chain fatty acid. So that's why even in fatty acid, they do not produce glucose through gluconeogenesis process. Okay, due to this irreversible phenomena. Now third is the thiamine pyrophosphate deficiency. It takes place due to the chronic alcoholic consumption. The deficiency of thiamine pyrophosphate due to chronic alcoholic consumption, and it leads to the defect in absorption of thiamine, and it leads to the defect in conversion of thiamine to thiamine pyrophosphate, and it leads to disorder, that is Wernicke-Korsakoff syndrome. That is Wernicke-Korsakoff syndrome. Wernicke-Korsakoff syndrome. Okay, students, there are some symptoms that are GOA MP. This is a mnemonic. G mean global confusion. O mean ophthalmoplegia. Ophthalmoplegia mean lose in the muscle coordination, muscles around the eyes, and arms and legs. A mean ataxia. It is also loss losing the muscle coordination of eyes, arms, and legs. M mean memory loss, and last one is psychosis, mean brain damage. So these are the symptoms of this syndrome, Wernicke-Korsakoff syndrome: global confusion, ophthalmoplegia, ataxia, memory loss, and psychosis. So the defect in thiamine pyrophosphate, which is due to chronic alcoholic consumption, it leads to defect in absorption of thiamine and defect in conversion of thiamine to thiamine pyrophosphate. They all are lead to the blockage. They all are lead to blockage in pyruvate dehydrogenase complex and leads to accumulation of pyruvate, which leads to the neurological manifestation, and also it leads to the decrease in production of ATP and inhibits the TCA cycle. Okay, students. So this is the importance. This pyruvate dehydrogenase complex. This is a link reaction between glycolysis and TCA cycle, and due to irreversible phenomena, not all fat converts into glucose except glycerol and propionyl CoA, and there's defect in thiamine pyrophosphate due to chronic alcoholic consumption. It leads to defect in absorption of thiamine and defect in conversion of thiamine to thiamine pyrophosphate, which leads to disorder Wernicke-Korsakoff syndrome. And their symptoms: global confusion, ophthalmoplegia, ataxia, memory loss, and psychosis. And pyruvate accumulation, it leads to the neurological manifestation, less ATP production, and inhibition of TCA cycle. So students, it was all about pyruvate dehydrogenase complex, their steps, regulation, and importance, and this disorder Wernicke-Korsakoff syndrome. If you have any query, you may ask in comment section. If you are new on this channel, then kindly like, share, and subscribe to my this channel. Thank you.